Good morning / afternoon, everyone. Sorry I couldn't be in class today. Hopefully quiz went all right. Let's take a look today at graphing some logs. We talked about solving equations. That's going to be really helpful here. We talked about rewriting for exponential and for log and kind of going back and forth. So this is going to be helpful for what we do for this video. So when we talked in the beginning of this chapter, we use this word inverse because we know that's the inverse of exponential equations. So, if we were to rewrite what we see that I boxed here in log form, what would we do? Well, remember how we switch this, right? We say now that like y, which is our output, is equal to the log base 3 of x. Okay, so we dealt a lot with graphing exponentials like what I have originally last chapters, right? So we have our x and our y. We want to plot 3 points. We typically chose some easy ones like those. Plug them in. 3 to the negative first is 1/3. 3 to the 0 power, anything to the 0 power is 1. And 3 to the first power is just 3. Okay, cool. Now if we use this inverses, we're basically switching x's and y's. Right? So these two equations are inverses of each other. So what was x is now the new y. Maybe it helps if I change colors here. You know how that works. So let me change this. Let's go blue. All right. So we are going to take a look at log base 3 of x, understanding that we are going to take all of these x values and now make them y values over here. Like so, we are going to do the same thing for what was the y is the new x. This is just showing the definition of what a derivative does, switches x's and y's. Okay. So we already saw this a little bit. So what the graph ends up looking like, instead of having the horizontal asymptote that purple, this was the original one. So this was the f of x is equal to 3 to the x. Now our blue function is going to be y equals log base 3 of x. So let's plot these points. So negative 1 comma 1/3 is about there. Whoop. Switch that. 1/3 comma negative 1, I'm sorry, is about there. 0, 1 comma 0 is going to be right there. And 3 comma 1 is going to be 1, 2, 3 comma positive 1 there. Alright, so we have something that looks like this. Remember how we talked about at the beginning of this chapter what was a horizontal asymptote for our exponential, which was, our horizontal asymptote here. Horizontal asymptote was y equals 0. Y equals 0. Now we have a vertical asymptote, just switching those, x equals 0. So that's going to be this line going right here. Right, so that's going to be our vertical asymptote. So everything positive, we talked about how log of whatever base can't have a negative number inside. Alright, so going forward, let's take a look at a couple examples. We're going to basically use this same strategy. You essentially switch this to exponential form, look at what that would be, and then all you're going to do is switch those x's and those y's when you put it into the actual logarithmic form. Alright, so looking at example number 1 here. F of x is log base 2 of x. Alright, let's take a look at what this would be. Let's just call this y for a second. This would be the same thing as 2 to the y power is equal to x, right? Okay, cool. So exponential, a little bit easier to deal with. We're just more comfortable with that. So now let's take a look at our table, x comma y. Now typically, when we were to do this, we were plugging in values here and thinking about what that value has to be. We're going to do the same thing here. We're just, instead of putting x's in and getting y's, we're going to look at this exponential form of this equation and plug in y's and get the x's out. Okay, so if I plug in our normal numbers, negative 1, 0, and 1, what are the inputs from the log function that would get us this? So looking at this exponential, 2 to the negative first power is 1 over 2. 2 to the 0 power is 1. 2 to the first power is 2. Okay, so let's put these points together. X is 1/2, y is negative 1. Okay, so there's my first point. Now x is 1, y is 2, or sorry, x is 1, y is 0, And then the next one, x is 2, y is 1. Okay, so we see this curve. Just like exponential, we have to understand what the general shape looks. So it kind of hooks over the top here. We know our horizontal asymptote because it hasn't shifted at all. Or sorry, our vertical asymptote is at x equals 0, and we just kind of get closer and closer, but never goes across that line. Okay, example number 1. Now let's take a look at some shifts. All right, first step, we want to get x by itself. That's why we talked last class about just solving these equations. We're kind of just rearranging this. So f of x, we'll call this y. So I would get 2 to the y power is equal to x plus 2, right? Get rid of that log, put it in exponential form. Now to get x by itself, we're going to go 2 to the y power minus 2 would now equal x. And this is what the form is we want to take a look at for this equation. Okay, so let's make our table. We see that we're shifting down 2 units. So let's plug in some x's and some y's by really starting with the y's and figuring out what x would have to be with that. So some easy numbers for y to be. Again, no shifts left or right, so let's go -1, 0, and 1. Now 2 to the negative first power is 1/2. So this would be 1/2 minus 2, right? So 1/2 minus 2 is the same thing as just -1.5. -1.5. If I plug a 0 in there, so that would be just 1 minus 2. 1 minus 2 is the same thing as just -1. And 2 to the first power, this gives us 0 back. Okay, so we have these points that we're going to graph now. I just want to show the work a little bit. So -1.5, comma -1. -1.5, comma -1 is about there. We have -1, comma 0, and we have 0, comma 1. So we have this curve. Notice how this plus 2 in our equation is really shifting to the left 2 units. So what was our vertical asymptote of x equals 0 is now shifted over to the left. So x equals -2. Okay, so there's my vertical asymptote. I keep saying horizontal. So we have this hook over to the side. We have this getting very, very close, and that would be our second example there. Okay, so the key thing, making sure you understand how this shift will change, in this case, our vertical asymptote. Alright, so we took a look at the basics over here. We took a look at shifts to the left, or just horizontally in general. Obviously, if I go to the right, it would be x minus 2 on those parentheses, so then I would shift to the right 2. Now let's take a look at this one. So this is going to be shifting my graph up 2 units, but we don't really have to worry about that. Let's go through our process the same way. Okay, so if I want to write this in exponential form, remember the parentheses that we don't really see, they're going to be right there. So this is going to be 2, so y minus 2, subtracting that over, would be equal to log base 2 of x. Just like when we solve our equations, we want to get that log by itself. Because now I'm going to rewrite this as 2 to the y minus 2 power is equal to x. Now remember when we talked about when we shifted x's horizontally for our exponential equation, we wanted to plug in numbers that would make that exponent, so this in this case is that y minus 2, what shifts that, right? So how can I get some easy numbers for the y values to plug in here? Well, 2 would make that just be 2 to the 0 power, right? So 2 to the 0 power gives us 1. I go 1 below that, so I plug in a 1. 2 to the negative first power is just positive 1/2. And then now I would plug in 3, 1 above that, right? Just like before. So 2 to the 3 minus 2 power is 2 to the first. And 2 to the first we would just write as 2, obviously. Okay, cool. So now we have our points, 1/2, comma, positive 1. We have 1, comma, 2. And we have 2, comma, 1, 2, 3. So again, there's our 3 points. Understand the shape. Understand we're not shifting left and right, so my vertical asymptote is going to still be at y equals 0. sorry, x equals 0. I keep flip-flopping those. X equals 0 because it's vertical. And then we have our curve right there. And there's our third graph. Okay, last one, we're going to see shifts both ways, right? So once I see this, I see that I'm going to shift to the right 3, which would change my vertical asymptote from x equals 0 normally to x equals 3 over. This plus 4 would just obviously shift everything up 4. And let's just take a look at how we would solve and put this into exponential form. Alright, so first things first, I would subtract that 4 that's on the right side of this equation. So I'd have y minus 4 is equal to the log base 2 of x minus 3. Okay, now I rewrite this, 2 to the y minus 4 power, put some parentheses, is equal to x minus 3, because that log would be gone because we just rewrote it. And on my last step, 2 to the y minus 4 power plus 3 is equal to x. And at this point, once x is by itself, this is where I'm going to pull up my table and figure out some numbers to put in there and then take that and put into the graph. So we have our y's and our x's. Some easy numbers for y would be 4, because that makes the exponent 0, just like before. We put in a 3, one below, and then a 5, one above. Okay, so let's see what these numbers end up being. 2 to the 3 minus 4 power, so 2 to the negative first is going to be 1/2 plus 3. So, right, so we could write this as 3.5 if we wanted to. Just use that. Plug in a 4. 2 to the 0 power is 1. 1 plus 3 is equal to 4. And then here we go. 2 to the 5 minus 4 power would be 2 to the first. So 2 plus 3 gives me 5 back. So just notice that switching, we're plugging in y values, which is a little bit different for this, but that just makes it a lot easier if we look at it from the exponential form. Alright, so let's plot these points. 3.5, 1, 2, 3.5, comma 1, 2, 3. There's my first point. 4, comma 4, that's a little bit easier. And 5, comma 5. 1, 2, 3, 4, 5, comma 5 right there. Cool. Alright, connect the dots, hook it to the right there. Notice your vertical asymptote is going to be shifted to the 3 units to the right, so that's going to be x equals 3 is the vertical asymptote. And it gets very, very close on this side. Whoop, kind of missed that one. Very close right there. Cool. Alright, so those are our 4 graphs. That's the process. Now what I want you guys to work on is finishing these 6 examples and then these 6 for solving equations, because obviously, you know, we want to get a little bit better at that. Helps with the graphing too. So hopefully you guys learned a little bit of something. Feel free to work with one another and see how you do on these examples. Answers will be posted. Good luck.